guys, welcome to your the continuing part of your physics. Alright, so for 2.4 and 2.5, we will focus a lot more on the calculations. Okay, so you will have a few formulas that you need to know in order to calculate. Alright, so before you start this chapter, make sure that you already understand the meaning of current and also voltage. Alright, it's very important before you start with this particular part, that you already studied what is current, what is resistance, and then you have already studied on the series circuit and the parallel circuit. Okay, so let's not waste time. Let's go into your EMF, or what we call it as electromotive force. Alright, so what is EMF? Okay, technically if you look at the definition, right, they mention this: work done by source in driving a charge blah 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 around a circuit. Okay, so technically what is EMF? If they ask you EMF, very simple. You just look at your battery. Alright, the voltage of your battery is the EMF. Okay, so technically what does this mean is that, okay, your voltage of your energy source. Alright, so if we say, okay, so if you say that your battery is 1.5 volts, okay, so this is the EMF, right? So what does this mean is that for every for one charge of coulomb, alright, so you must remember coulomb, 1 coulomb, I hope you still remember this. 1 coulomb is referring to how many electrons, if I'm not mistaken, 1.6 times 10 to the power of 19 electrons, right? So when we say your EMF, oops, is equals to 1.5 volt, meaning that for all these electrons to move, if I want all these electrons to move, I need to give them 1.5 joules of energy. Okay, so that is what we mean by voltage. Remember that I mentioned in the previous lesson. Okay, voltage is referring to the energy needed for the electrons to move. So if my battery is 1.5 volts, meaning that the battery is going to supply 1.5 joules of energy so that the electrons can move in the circuit. Okay, so in other words, alright, voltage for your energy source or your battery is what we call as the EMF. Okay, so if they ask you EMF, you just look at the battery. Straight away you look at the battery and see what is the voltage. Alright, and sometimes they will ask you to calculate the EMF of a circuit. So let's just do a simple revision of on your what we call series and parallel. Alright, so if you have a series circuit and a parallel circuit, okay, remember for a series circuit, okay, the voltage is separated or is divided, is shared, right? Whereas for parallel, the voltage is always the same. Okay, so if let's say I have a circuit, alright, and then here I have 1 light bulb, 2 light bulbs, okay, and then this light bulb, let's say is 1 volt, okay, and then this is 2 volts. Alright, so if I calculate the EMF for this circuit, meaning EMF, meaning I need to know how much voltage is the battery supplying, right? I just add up the voltage here. Okay, so this one is the EMF of the circuit is equals to 3 volts. Okay, because for series circuit, your voltage you need to add up. Okay, or in another way, we can say that your EMF is actually the total voltage, okay, in the circuit. Alright, to make it easy for you to understand. Okay, so if we say that a circuit, electrical circuit, the EMF here, the battery sources is 3 volts, right? Meaning the highest will be 3 volts. Okay, impossible that you say that your source is 3 volt and then suddenly when you measure using the voltmeter it goes up to 5 volts, meaning something is wrong with your circuit. Alright, so That is one example of series circuit when you want to calculate the EMF. Now what about for parallel? Okay, so you need to remember that for a parallel circuit, right, your voltage will always be the same. Okay, so if this is 2 volts, this is 2 volts. Okay, so in this sense, my EMF is also 2 volts. Alright, because this one is parallel. So if this one is 2 volts, here is also 2 volts. Okay, that is the meaning of the relationship here. Alright, so you need to understand how to apply the series and parallel circuit to help you find the EMF. Okay, so technically EMF basically is just the total voltage of the circuit, or in other words, the voltage of the battery. Okay, so I hope you understand what is EMF. Alright, alright. Okay. Next part will be to compare what is EMF and potential difference. Now these two things, okay, these two terms, alright, basically their unit is the same, it's still voltage, just that one is referring to the battery EMF. Okay, another one, potential difference, is actually referring to the voltage in the circuit. Alright, meaning at any point. Okay, so what do we mean by potential difference? So potential difference is the voltage of any 2 points in the circuit. So what do we mean by this? Alright, so technically let me just move this first. Okay, now you need to remember that when we talk about what we call voltage, right, we're referring to the energy in the electrons, right? So when when the electrons are traveling in the circuit, for example this part, okay, when they travel from here to here, right, they are going to release the energy that they have. Okay, so if I say here don't use 3 volts, keep using 3 volts, change. Okay, let's say if I say my battery is giving them 5 volts, so meaning every time the electron moves in the circuit, right, they are going to release 5 volts into the circuit. So I supply them 5 volts, meaning I supply them 5 joules of energy in the beginning, and then when they start to move, right, that 5 joules of energy will slowly dissipate, meaning they will slowly give off the 5 joules of energy, and then once they have given off the energy, they will go back to the battery and take another 5 joules again. So technically this one is like your this is the point where they refuel, right? Electrons take energy, go in your circuit, release the energy, go back to the battery, refuel. Okay, so this is what they are doing. Alright, so when we talk about potential difference, is that we measure at any 2 points. Let's say for example from this point, okay, until this point, these 2 points, how much energy is the electrons releasing? Okay, now before I go into the part about what we call internal resistance, I'm just going to give you a very general concept. If let's say I have 5 volts here, right, and then I only have one light bulb here, so technically, theoretically speaking, the electrons will release 5 joules of energy to your light bulb. Okay, so meaning when you measure the potential difference here, right, okay, you're going to get 5 volt, let's say for example, right? But in real life, this does not happen, okay? Because the voltage given will always be slightly lower than your EMF. So maybe when you measure the potential difference here is only maybe 4.8 volts, okay? But why? So here is the question. Why when they travel from here to here, but right, I have 5 volts, what? But why suddenly decrease to 4.8 volts? Where is the other 0.2 volts? Why is it missing? Okay, so this is uh, where we need to consider the internal resistance of the battery. Okay, alright, but before you go into that, I would just like to make a point here will be that your potential difference is the voltage that you measure at any 2 points in the circuit. So if you say you measure here 4.8 volts, right, meaning when the electron moves in the circuit, they are moving with 4.8 volts. 0.2 volts are missing, but why missing? Okay, this one we will talk about it in the internal resistance part. Okay, so basically EMF and potential difference. Okay, to make it simple, this one is battery. Okay, voltage, battery voltage lah. Alright, whereas for EMF, to put it in a simpler way, is the voltage in the circuit. Okay, so that is the difference between these two things. Alright, oh my god, can't believe I spent so much time explaining just about EMF and potential difference. Okay, but I just want you to really understand. Alright, okay, so that will be the difference between EMF and potential difference. Okay, so that is why if you see here, there's an explanation. Alright, okay, oh, there's one more thing that I forget to mention. One will be open circuit and also closed circuit. Now when we talk about open circuit, meaning no current, okay, or current is not moving. Alright, whereas for closed circuit, meaning current is moving. Alright, so in this example here, right, you will see that the voltmeter is directly attached to the battery. Okay, now remember, current does not flow in the voltmeter. They are not going to go into the voltmeter. No. Alright, the voltmeter is basically just for us to check the energy released by the electrons, but the electrons will never travel in the voltmeter. Now in this case, since currents are not moving, right, meaning that if my dry cell is 3 volts, meaning meaning the electrons all will be having 3 volts, not moving, so they keep all their energy. And then when they start to move, meaning in the closed circuit, when they start to move, they are going to release their energy. Okay, so it depends on what type of energy they are going to release. So like for example in this case, right, as the currents travel, okay, when the electrons travel here in the circuit, right, and then when they go through the light bulb, what happens is that during this part, okay, you are actually converting the electrical energy to light energy. Okay, so if let's say so for example I use back this example, right, I give them 5 volts of energy, and then as they pass through the light bulb, they are going to what they call donate their energy to the light bulb. Okay, so how much they are giving to the light bulbs, we are going to measure using the voltmeter. So let's say for example if I measure here is 4.8 volts, right, meaning they are donating 4.8 joules of energy to the light bulb. Okay, basically you are converting an electrical energy to the light energy. Okay, whereas for your battery, if you still remember your chemistry, alright, your battery, you are converting what energy to what energy? Chemical to electrical energy. Okay, so these are the few basic concepts lah. Alright, when we talk about open circuit and closed circuit. Okay, you just need to remember when we say open circuit. Okay, the meaning of open circuit meaning the switch is not connected. Okay, switch open. Switch closed meaning the circuit is connected. Later I'll show you one example. Alright. Okay, so if you see here definition, alright, so they have the same unit. Okay, you need to remember both are the same unit, EMF and potential difference. Okay, so we are using voltmeter to measure. Alright, okay, so technically if you see here, between is defined as energy converted from electrical to other forms of what you call energy. Okay, so how do we solve questions involving EMF and also potential difference? Okay, and then here I'm going to explain why when you connect to a circuit, right, your potential difference or your voltage reading will actually what they call reduce. Okay, so this is an experimental setup. So you have your battery, your voltmeter, you have your switch. Okay, this is what we call as open. Open meaning this is not connected yet. Okay, so that is why open, your ammeter reading is 0. Okay, remember current not moving. Okay, so remember when we say open circuit, meaning the switch is open, it's not connected yet. Alright, so when the switch is not connected, and then when you measure with a voltmeter, okay, you get 3 volts, right? So this is the EMF, meaning I know that my total voltage in the circuit is 3 volts. Okay, I know the battery is 3 volts. Now, when you connect the circuit, okay, closed, alright, you will see that your ammeter reading got value, meaning current is moving, right? But then your voltage reading has reduced. Now this is a question, why will it reduce? Since I only have one light bulb, so theoretically speaking, shouldn't this one light bulb get all the 3 volts? Correct or not? If I have two different light bulbs, of course they will need to share, right? But in this case, why this light bulb is not getting the full 3 volts? Now the reason being is because here inside the battery we have what we call the internal resistance. Okay, now if you remember the meaning of resistance, meaning something that stops you from moving, right? Okay, now in an electrical circuit there are two types of resistance. Okay, one is called external resistance. Okay, so let me just write it for you here. Okay, if we say external resistance, this one is referring to the circuit resistance. Oops. Alright, meaning the resistance that you can find on the circuit. Okay, and then another one is the internal resistance. Now internal resistance, this whole thing, this term is referring to resistance inside the source or electrical component. Okay, meaning what? So let's say if I draw that you have one resistance here now. Normally resistance will draw it as rectangle, right? So okay, right? So this one is external resistance. Okay, now internal resistance, it's either inside the source or electrical component, meaning inside your battery and your light bulb. Oh, excuse me. Alright, inside your battery and light bulbs, inside this electrical component, they have their own resistance. Alright, so when we do calculation, we need to consider two types of resistance. One is the resistance outside the circuit, another one is inside, but inside where? One is the source battery, another one is the light bulb. Alright, now for this example, I'm going to assume that light bulb has no internal resistance. Okay, I'm just going to ignore the internal resistance in the light bulb, okay, just to make you understand. Okay, now when you have internal resistance, meaning what? As the electron travels into the circuit, right? Okay, when they travel from here to here, they go around in the circuit. Okay, every time when they go back into the battery and come out, okay, their voltage will drop. Okay, why? Is because whenever they travel back into the battery, right, due to the internal resistance, okay, their energy level will go, or what they call, will go down. Okay, um, in other words, right, it's basically like this lah. If let's say you're traveling in a car, all right, you travel from here to here, you have 5 ringgit here. When you travel go back, here you have a toll. So every time you pass through, you need to pay your toll. Let's say 50 cents. So you're left with 4 ringgit and 50 cents. So it's just like that. All right. It's the same thing for your electrons. Okay, when you move in the circuit, right? Okay, not only you need to consider external circuit but also internal circuit. Like internal resistance. Okay, external resistance and internal resistance. Okay, meaning the resistance inside the battery. Every time when the electron moves, okay, when they go back to the battery to refill, right, just now I got mentioned that they need to go back to the battery in order to refill back their energy. The moment they enter the battery, they have to pay toll. Okay, so in other words, your net will always be lesser than your EMF. Okay, that's why in a circuit, right, very rare you will see um, light bulbs getting the exact voltage as the battery. Okay, because battery itself you have internal resistance, so the voltage value will always slightly be lower. Okay, so if you see here, right, the explanation here is given here, right? Compare the difference. Okay, now for this one, if they ask you what is the work done, okay, in moving 1 coulomb charge around the complete circuit, okay, meaning this one they are asking for the EMF. Alright, so work done, remember if you say 3 volts meaning 3 joules lah. So technically in this case, this is your EMF. Okay, I did mention this now. Alright, but if they ask you the work done in moving 1 coulomb of charge across light bulb, okay, this one they are asking for the potential difference. Alright, now your potential difference is lower. Okay, meaning that when the electrons travel, they are releasing 2.6 joules of energy. Alright, now the reason why your reading is your reading drops is because of the internal resistance. Okay, so remember that the reason why your voltage will be lower is because of the internal resistance. Okay, so if we say that the light bulb is taking 2.6 volts, right, meaning that they are supplying 2.6 volts of energy, and then the light bulb will convert the electrical energy into light energy. Okay, meaning the 2.6 joules of energy will be converted into light. Okay, and also heat lah. Right, later we'll talk about efficiency. Okay, so technically that is internal resistance. Alright. Okay, so this one is a more lengthy explanation. Okay, you can go through the explanation. Alright, but the important key point here is this. Alright, so you see here internal resistance causes the loss of energy. Okay, that is why the voltage will be lower. Okay, why? Because they are used to overcome the internal resistance of the battery. Okay, so technically when you have resistance, you need to use a certain amount of energy in order to overcome the resistance. Okay, meaning if someone is blocking you, right, okay, inside the battery, okay, wait, let me draw a bigger one so that you can see. Okay, so let's say this one is the battery. Okay, this one is positive, this is negative terminal. Alright, and then your electrons is coming back to refill. Okay, but as they enter, right, there will be something to stop them. Okay, you have resistance. Okay, okay, let me just write this as resistance. Alright, so in order for the electrons to overcome the resistance, they need to use more energy. Alright, so you need to need more energy. Okay, in order to overcome, okay, the resistance so that they can pass through. Okay, you need more energy to pass through, so it makes sense, right? If somebody is stopping you, of course you need larger energy in order to go through them. Okay, that is why your energy level will drop. Okay, so remember that your what they call potential difference will always be lower than EMF. Okay, EMF is like the max voltage that you can have in your um, electrical circuit. Okay, so your equation that you need to know is this one. Alright, so this, you can either use any equations lah, but normally we use this. Okay, or sometimes we write it as like this. Oops. sometimes we really expect this. Okay, I R plus R. Okay, so big R here is the total resistance of the circuit, meaning external circuit, big R. Small r is referring to the internal resistance. Okay, both have the same unit, ohm. Alright, okay, and then E here is referring to the EMF. Okay, so remember, this is the formula that you're going to use for calculations. Alright, sometimes you need to use this also. Okay, but basically these two things are the same because V is equals to IR. Okay, remember that we learned this in your series and also parallel. Okay, V is equals to IR. So this one we can substitute here. Alright. Okay, so this one is very important for your calculation. Okay, comparison between total EMF and total internal resistance. Okay, you need to know how to calculate total EMF and total internal resistance. Alright, now remember this is a series circuit. Okay, this is series. Okay, you need to remember the formula for series. Your voltage you need to add up. Okay, you're going to add up your voltage. Alright, resistance also you're going to add up. Okay, but for parallel, double L, yeah. Okay, parallel. Okay, so for parallel circuit, right, you need to remember that your V will always be the same. Okay, so here and here, if this one is 1.5, this is also 1.5 volts. Now, total internal resistance, okay, you take half. Okay, if this one is 0.5, you have 2. Okay, you're going to take half of the total resistance here. Okay, you just divide by 2. Okay, if you have 3, then you divide by 3. Alright. Okay, you're going to divide off the what they call resistance. Okay, so technically for calculations, the two formulas they are going to use to calculate a lot is this one and also this one. Alright, so show one example on how we use this formula to calculate. Alright, so you need to know what you need to find. Okay, internal 2 volts dry cell. So remember 2 volts dry cell. So meaning my EMF is 2 volts, meaning this one EMF E is 2 volts. Okay, and then they gave me internal resistance, okay, 0.5, meaning my small r is 0.5 ohms. Okay, then my current is 0.4 ampere. Okay, but you need to make sure you need to determine is what circuit. So this is a series circuit. Okay, so they want me to calculate R, meaning they want me to find this one, big R. Okay, so technically you are just going to use this formula to calculate the resistance. Alright, so you just substitute to this formula. So this one is 2 volts, is 0.4. Alright, R plus internal resistance is 0.5. Okay, so this one you bring this over, 2 divided 0.4, you're going to get 5. And then you have R plus 0.5. And then you are going to bring this over minus. So this one is 4.5 ohm. Meaning this one 4.5 ohm. Okay, whereas this one is battery. Alright, so voltmeter reading in the closed circuit. Okay, meaning they want to know what is the voltmeter reading in a closed circuit. Remember, closed circuit meaning current moving, right? Meaning this one is connected, meaning the current is moving. Okay, if it's open circuit, meaning you just refer to the battery, 2 volts. Alright, since it's a closed circuit, we need to calculate the voltage in the circuit. So calculate voltage in the circuit, we use this one. Alright, I multiply to R, right? But this R is the total resistance here, meaning outside here. Okay, so this one will be 0.4 times 4.5. So this one I think you will get 1 point input. Okay, so technically that is how you calculate. Okay, you just need to understand what you're finding lah. Alright. Okay, so I believe that is it. Okay, 3 resistors are connected. Alright, so all these questions I will explain in more detail okay, during our live session. Okay, so that is the first part for the not first part the second last part of your chapter 2 2.4. Okay, see you in your next lesson will be the final part of chapter 2. Bye.